See now? Now, what do you think? Too bright? Way too bright? Okay. Okay, over here, who cannot see it? Raise your hand. Who can see the board? The board. You can see the board? Get closer. That's all I can do. This pretty bright in here. Like on the stage. Baby, baby. There you go. Oh, that's all I can do. Alright, that's there. If you can't see it, get closer. Okay? You have to sit closer. Okay, when you draw Lewis dot structure, again, it's very important, so make sure you pay attention. Okay? So, Lewis dot structure is a structure that tells you about electrons. Okay? How many electrons are there in the structure? And you have to add all of them into the structure. Okay? So, first thing, I'm going to give you the process, the step. Okay? Don't skip the step. Okay? Step by step. Okay, Lewis dot structure. What do we do first? Count electron. Okay? We're going to count the valence, not all electron, only valence electron. Right, we're going to count valence electron. Okay, write down. Okay, after you're done with counting valence electron, we're going to arrange atom. Okay, for example, we have OF2 right here. So, how many electrons are there in oxygen? 6. We have 6 fluorine. 7. 2 of them. 14. Total of 20. Okay? So we have 20 electrons. We're going to add those electrons into the structure. Now, next one. We're going to arrange atom. Arrange atom. Yeah. With En. Low En. Low electronegative atom. That's going to be central atom. Higher En, that's going to be high En, that's going to be non-central. Now, if I ask you, comparing between oxygen and fluorine, who is central atom? Oxygen, okay? Fluorine is the highest, right? FOCl, NBRS, the first 6 highest, okay? The 6 highest. So, oxygen is going to be in the middle, and fluorine is non-central. And sure, you're going to bond them with a single bond, okay? You're going to bond them with a single bond, like that. Number 3. We're gonna start adding electron. Add electron. By making non-central octet first. Okay, make non-central atom. octet. Okay? Make non-central octet first. So you have fluorine as non-central, okay? Make octet. What does it mean, octet? 8 electrons, right? Now we have 2, right? Fluorine, covalent, oxygen, so you have 2. So you add 6 more. 1, 2, 3, 4, 5, 6, 7, 8. Octet. The other fluorine do the same thing. 1, 2 in the bond. 3, 4, 5, 6, 7, 8. Alright, do step by step. Alright, skip it. Do step by step. If you have electron left, the rest you add to central. Alright, so we have 8 on the left, 8 on the right. So how many more do we have left? We have 2 more, so we add in central. So we have 4 more. Add central. 1, 2, 3, 4. Okay? And last one. After you add all electrons, make central atom octet. Yeah, we're going to talk about that later. Okay? 3.3, make a central atom octet. We'll talk about that later. So, make sure everything octet. Fluorine, 1, 2 in the bond, 3, 4, 5, 6, 7, 8. Octet. Happy. On the right, fluorine, 1, 2, 3, 4, 5, 6, 7, 8. Happy. Oxygen, is it octet? 1, 2, 3, 4, 5, 6, 7, 8. Happy. Or octet. Okay? Now let's try S2S. S2S. Don't skip the step, okay? I'm warning you right now. I know you know the answer, but when things get complicated, if you skip the step, not familiar with these 3 steps, yeah, you screwed. Seriously. Okay? So make sure step by step, even an easy one, try with an easy one first. We have H2S. Oh, one more thing. When we arrange atoms, yeah, low electron negativity is central and high EN is non-central. What about hydrogen? Can hydrogen be a central atom? Hydrogen never be a central atom. Why not? It has only 2 electrons, the maximum. It cannot have many hands. Hydrogen never be a central atom. Okay? What about fluorine? Can fluorine be a central atom? Why not? The highest electron negativity. So fluorine and hydrogen never be a central atom. Okay? Fluorine and hydrogen never be a central atom. This one you're going to have sulfur as a central atom. Alright, do step by step. Alright, help me. Start with the first one, count valence electron. So what do we have? Hydrogen. We have 1, right? 2 hydrogen is 2. Sulfur, 6, total of 8 electrons. Right? So we have 8 electrons. We're going to add it to the structure. Now, second one, arrange electron. And sure, hydrogen is non-central. So we have H, S, and H. Bonded with single bond. 4 electrons so far. Okay? Now, make a non-central octet. Hydrogen is full, it's just 2. Right? Hydrogen kind of a little bit exceptional, but normally hydrogen is, get only 2 electrons. Right? So 2, 1, 2, fine. Hydrogen on the right, 1, 2, fine. Now, so 4 so far. How many do we have left? 4. Add to central. Okay? 1, 2, 3, 4. Yeah, looks like water. This one. So make sure everything octet, everything is stable. Hydrogen needs 2 to be stable. 1, 2, happy. On the right one, 1, 2, stable, happy. Alright? Sulfur, make sure it's octet. 1, 2 on the bond, 3, 4 on the bond, 5, 6, 7, 8, happy. Everyone happy. Ooh. Okay? Now, let's try CO, carbon monoxide. Let's try carbon monoxide. It's going to be a little different. Okay, step by step. Count valence electron. Arrange electron. and then add electrons. Who's done with carbon monoxide? What's your name? Let me see. Alright? If you're done, help me. Okay? What do we do first? Count electrons. Okay? Carbon. 4 oxygen. 6 total of 10 electrons. Okay? So who's central? En, electronegativity. Who's central? Carbon, right? So you're going to make oxygen octet first. Okay? So you have carbon, oxygen, bond with single bond. Alright? Now, we're going to make non-central octet first. We know oxygen, higher electronegative. Okay? So make oxygen octet. 1, 2, 3, 4, 5, 6, 7, 8. Right? So we have 8 total. How many do we have left? 2. We add 2 on the carbon. Right? We add on the carbon. Okay? So step 1, 2, 3, 5. And the last one, make a central octet. I didn't write on that. It's on the sheet. I make the central octet. Oxygen already octet is fine. But carbon, how many carbon we have? How many electrons carbon have? 1, 2, 3, 4. Just 4. How many more does it need? 4 more. So what do we do? Use lone pair of oxygen from double bond. Use lone pair of oxygen from more bond, triple bond. Alright, you're gonna get triple bond with oxygen. Alright, let's take a look if everything octet, everything is stable. Alright, let's take a look. Oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Absolutely octet. What about carbon? 1, 2, 3, 4, 5, 6, 7, 8. Octet. Happy. Sorry? Why can't we have double bond in here? I'll show you why. I'll show you why. Okay? We're gonna talk about formal charge later. Okay? Are we okay on that? Alright? So we have 3 steps. Count electrons, arrange atom by En, and then you add electrons. Let's try this one. NO plus. Alright, I'm gonna get faster. Alright, I'm gonna get faster. Right, do step by step, okay? Count electrons, arrange atoms, and add electrons. Make everything octet. Who's done? Raise your hand. Who's done? Okay. Alright, if you're done, help me. Alright? Nitrogen, how many electrons? 5. Oxygen, 6. And we have plus, what does it mean? Lose 1 electron, -1. So total of 10 electrons. Okay, who's central? Nitrogen is central, right? So we make oxygen octet first, right? Now 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Right? So 8 total. How many do we have left? 2, add 2, or nitrogen. Okay, add to the nitrogen. Okay? Oxygen already octet, we're fine. But we're going to make central octet too. So nitrogen have 1, 2, 3, 4. 4. So you need 4 more. What do we do? Take lone pair from double bond. Another lone pair from triple bond. Okay? Need 4 more. So give 1, 2, 3, 4. So you should get triple bond. Okay? Alright, make sure everything octet. Oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Octet, happy. Nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Octet, happy. Alright? Let's try. Okay, some molecules can have resonance form. Okay, resonance structures. Okay, using NO2 minus. If you don't nitride NO2 minus, do carbonate CO3 and 2 minus. Make sure you do step by step, don't skip step. Okay? Yeah, the problem, the structure will be more complicated, more and more complicated. This one's still easy. This from the lab, right? NO2 minus, how many resonance form do you have? How many structures? 2 structures. You get 2 structures, all right? All right, who's done NO2 minus? Help me, okay? So nitrogen, how many electrons? 5 electrons. Oxygen, 6, 2 of them, 12, right? So 12. And we have negative 1 plus 1. So total of 18 electrons, all right? Now, good start, all right, good start. NO2, who's central? Nitrogen, lower EN, N and O, bond with single bond, okay? What next? Make electron, add electron, we make non-central octet first, okay? Non-central oxygen, 1, 2, 3, 4, 5, 6, 7, 8. On the right, the same thing, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, 16. 2 more, add to nitrogen, alright? Step by step. Make sure everything octet. Oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Left, right, the same thing, okay? What about nitrogen? 1, 2, 3, 4, 5, 6. How many more does it need? 2 more, what do? Take lone pair of oxygen from the bond, right? From double bond. So you get double bond on the left. Some of you can do on the right too, right? On the right. You get 2 resonance form. Okay? One thing that I usually do to make sure I get the correct resonance form. Take a look here. You have double bond on the left, double bond, and this structure, you have double bond on the left and single bond on the right, okay? In the next structure, you have double bond on the right and single bond on the left. Looks like it's from double, on the right it's from double bond, and on the left it's break bond. I do like that. Electron from double bond, you get structure at the bottom. Right? Double bond on the left, break bond, you get electron pair. And they can go back and forth. Go back and forth. This will make sure that you get the resonance structure, the right resonance structure. If this